Hi, I'm going to interview React, discussing about its API. Hi React,
Hydropulse.
what are all the APIs you have?
Use startTransition, memo, lazy, createContext, cas, act.
What is the use API?
Use can be used to read values from a resource like a promise or context. Here, use is used to read the count value from count promise and read the theme value from theme context.
But we already have hooks like use context to read the context and use effect where we can perform these async operations. Why do we need use API?
Unlike hooks, use API can be called within loops or conditional statements. Like hooks, use API must be called inside a component or custom hook. Also, when we pass a promise to use API, it integrates with suspense and error boundaries. The component calling use suspense while the promise passed to use suspense. If this component is wrapped inside the suspense boundary, the fallback will be displayed. Once the promise is resolved, the fallback will be replaced by a rendered component.
What if the promise gets rejected?
Then the fallback of the nearest error boundary will be displayed.
Again, we can implement this pattern without error boundary and suspense by passing two Boolean state set functions, one for success and one for error, to the child component from the parent.
Yes. But when you choose to implement these kinds of boilerplate code, there is always a possibility of bugs. Also, consider this example for the error boundary. In show count component, we have a button. On clicking this show button, the count display component is shown. Here, count display is not the direct child of app component. For these scenarios, you will have to pass the error handling flag through multiple levels which affects readability.
Yes, but we can pass the error state set functions through context. We can call use inside the try catch block and handle the rejected case inside the catch block.
No, use cannot be used inside the try-catch block. If you want to call use inside the try-catch block, you have to wrap your component inside the error boundary. Also, use cannot be used inside normal function calls. As an alternative to using the error boundary, you can provide a promise.catch method. When a promise passed inside use is rejected, then the value returned by the promise.catch method is used.
Noted. What does start transition do?
Start transition lets you mark a state update as transition. State updates marked as transition will be non-blocking. You need to pass an action function with one or more set function calls to start transition. The action function will be called immediately and all state updates which are scheduled synchronously are marked as transition.
Great. Since the update is non-blocking, the UI is highly responsive. What if I want to include state updates in async operation?
Any async calls awaited in the action function will be included in the transition but require wrapping any set functions after the await in an additional start transition call. Now, here is the example of using start transition for performing state updates in async operation. Whenever the query input is updated, the query results are fetched from a promise. After awaiting a promise, you have to call start transition again with another action function where you actually perform the state updates.
So, what is the advantage of using start transition here? I can just call the async operation in input on change event and my browser will not block my input as I type characters in the input field.
When start transition is not used, the query results will be rendered for every change you make. That is, as you type characters in the input field, the list component is rendered for every character change. But when you use start transition, whenever the input is changed and if there is already a pending transition, the pending transition is interrupted as transition are interruptible and a new transition is started.
Cool. How to know whether a transition is pending?
In order to know the pending status, you have to use the use transition hook which returns start transition function and is pending flag to indicate pending status of transition.
Noted. When do we need memo API?
Whenever a component is re-rendered, its children components are also re-rendered. Memo lets you skip re-rendering a component when its props are unchanged. Just wrap the component with a memo.
Does memo modify the past component?
No, memo just returns the memoized version of the component.
How do you determine whether the props to the components are changed or not?
By default, when new props are provided, each prop will be compared with object.is comparison. If it is changed, the component is re-rendered. Optionally, you can provide a compare function that takes two arguments, old props and new props. The comparison function should return true when props are the same or false otherwise. It is always a good practice to create a component with pure rendering logic, meaning a component should provide the same output for the same state, props and context. By wrapping your component in memo, you confirm that your component complies with this requirement.
Can you provide an example?
Sure, here the address component is memoized. When it is not memoized, whenever the name state changes in parent app component, then address component will be re-rendered. Since it is memoized, the address component will not be re-rendered whenever the name state gets updated.
I think I can wrap all my components in a memo.
Not necessary. Optimizing with memoization is only valuable when your component re-renders often with same exact props and its rendering logic is expensive. You can use React Developer Tools profile to see which component benefits most from memoization.
Great. I can use the memo function for components with expensive rendering logic. Can you explain the lazy API?
Lazy lets you defer loading the component's code until it is rendered for the first time. Normally, you would import the component statically. Lazy depends on dynamic loading of the component. You will pass a load function to lazy that will return a promise. When the returned promise is resolved, it should return an object with default property referring to the valid React component. Lazy returns a component that can be rendered. You will be placing the component inside suspense while the promise is still being resolved, that is, component code is still being imported. Suspense fallback will be rendered, otherwise, component will be rendered. You can also wrap this component with error boundary, so if the promise returned by the load function is rejected, error boundary fallback will be rendered.
Okay, what is the benefit of using lazy API?
It will reduce the initial load time of your app by reducing the bundle size, and your app performs better even in lower bandwidth. Optimizing resource usage is also the key to better performance.
Well said. Next, create context API.
createContext returns a context object that can be used to provide value to the context and read value from the context. While calling the createContext, we pass a default value. This default value is used only when there is no provider for the consuming component. A component can provide a value to the context with a provider JSX tag with value attribute. Any child component, regardless of how many levels deep it is nested, will receive the context value using useContextHook or useAPI.
So I have to use the same context object throughout the app code, right?
Yes, it is better to declare the context object in a separate file and you can import the same object like you import the component.
Good idea. When cache API is used?
It is used only in server components.
Oh, we are not discussing server components. When do we need an Act API?
Act is a test helper to apply pending React updates before making assertions. Act can be used to render a component or dispatch any events while testing the component. It makes sure that the component is rendered or the event is dispatched and the event is processed by the component before running any assertions. You will pass an async function to Act that does rendering components or dispatching events to the component. Here is the example demonstrating the use of Act API. Here a container is created, then a component is rendered in that container. You will await the act call passing an async function for rendering to make sure the component is rendered. You can dispatch events in the same way and do any assertions.
Intuitive. It was nice talking with you.
Thanks. Bye.
Bye. Thanks. If you find this video valuable, you may share it with others. If there are mistakes, please mention them in the comment section.